Our next presentation comes from one of our sponsors, Dell, Marc, Mendez, Bermond.
Good morning, everyone. I'm Marc Mendez, Bermond. I often joke with my American colleagues, you don't want to stand between a French guy and his lunch, so I have the difficult mission to stand before your coffee break. This presentation is about the tool that we developed to control our solutions, our large-scale solutions. Its name is Omnia, and we rely on OpenCHAMI. So this is about the rationale between these tools. Let me try to work this. Sorry, Brian, I have an issue here. Did you install the presentation I sent yesterday?
Yeah, that's the latest.
It's only one page. I'm sorry. Okay. Omnia is a tool that's developed with the community from HPC and AI, and it covers the needs of the new solutions that we have seen arising with the AI world. So basically, we needed something that is capable of addressing the needs of the AI workloads and still maintaining the compatibility with the HPC workloads.
Skip down there, there might be a PowerPoint.
Yep. In the Finder?
Yeah, see the PPTs?
Yes.
I don't know why the PDF is.
Good. Better. Cool. Sorry for this. So very quickly, the agenda. So AI HPC solutions, then the cluster management requirements with those new workloads, the architecture of Omnia, and the work we did with OpenCHAMI. So, as I said, AI and HPC solutions have changed. We are in a very new world with new technology in terms of software especially, but it's more than just the basic technology. It's also the users. The users have experienced the cloud systems, so they have more expectations, maybe in terms of flexibility, in terms of dynamics with their workloads, and that's something we need to take care of. The new solutions that we propose for the large-scale systems are very integrated, but it's not because they are very integrated that they are just large appliances. They are still made of power shelves, of CDUs, the servers. All of this has to be controlled and monitored from a cluster management point of view. So these solutions can be all mixed together. So you have GPU systems, you have CPU systems, especially for pre-processing the data sets or these kind of things, or traditional HPC. So all of that has to be included and managed by the cluster management. So if you translate that into the requirements, a unified platform is very much a requirement. So we need to consider not only a single cluster, something which appears like one big entity, it will be a pool of resources. That pool of resources can be partitioned between different workloads, different projects, different departments, so you can match both the applications, but also maybe the fundings from your entity. So, so this is one big need, and each of these partitions can be using Slurm or can be using Kubernetes. These are the most famous workload management systems that we have today. Of course, the analytics has to cover it all with the telemetry and the dashboards for your whole cluster, or per partition, per workload, per job. This is very much a requirement. We are very much focused as well at Dell Technologies onto the troubleshooting and the tracking of the replacement, the part that you replace in the cluster to in case of failure. So we can explore the causes and find the causes of these failures if we find some probabilities that are a bit higher in some areas. Of course, for the administrators, we want a fast, repeatable, and cluster deployment system. So we can turn any piece of hardware into a resource for the user. So this is very important, especially if you consider the dynamics, because I said you can partition your cluster, your pool of resources, but it's super important as well to think that all of that can change with time. So some projects will last a couple of months, a few years, but other will be very quick to turn around. So you'll have to get those resources back to the pool of available resources and transform that maybe. So from a Slurm node, you transform that into a Kubernetes worker. So we can grow each clusters with playbooks, and of course, in terms of simplicity and consistency, everything is included and controlled. So what we have come with is an infrastructure as a code for controlling your cluster. So everything is based on Ansible. You have some recipes for addressing, assigning your resources to the various partitions that you want to deploy. So what we recommend to our customers is to start with very simple recipes. Maybe a large pool will be used for a Slurm cluster, and then you'll have separate partitions for maybe a Kubernetes cluster for data processing, and then you may have for a department, for example, just for testing, another Slurm cluster. All of that is quite easy. It can be just modified on the fly, and that's the same for the updates. It's just based on Ansible. So if you simply redeploy your recipes with Ansible, you will update your nodes. So automation of the OS provisioning is also part of the tool. We will see that we have the OS images build pipeline that is included in that tool. We can configure every node, every partition differently, and we will join them to Slurm and Kubernetes. So these are the two workload managers that we support today. Of course, we integrate with Redfish, and the power management is included in the control plane. Then we have the telemetry cluster, which provides all the metrics required to have a good view and to track the activity on the system. So the iDRAC will report power, temperatures, and all the activity at the platform level, so at the motherboard level, and then we have the OS metrics that are collected by another channel. Everything is pushed to a Kafka message bus. It's stored in a Victoria Metrics database. So all the tools at the root of Omnia are open source and are developed by the community, and we integrate with them. So the dashboard are from Grafana, which is a standard, but it doesn't exclude the fact that you can plug any other solution to come and consume what has been stored in the Victoria database. As I said, everything is automated in terms of image build pipeline. So we have Git runners and Git actions that are at the core of managing the OS images. The inventory, the image inventory is with Pulp, another open source project. So we have the OS images for both the bare metal systems, and you can include the containers as well. Everything comes with the GPU drivers, the MPI libraries, the offset dependencies, and all of that. Everything is included in the tool. The great thing as well is the lifecycle and the configuration of the systems on the fly. So each node is treated as a stateless resource. So we can reimage it and reassign it with the playbooks in just a few minutes. I think we have measured the deployment time, which is kind of very fast compared to what we had in the past with other systems. But I have in mind 1,000 nodes in just a dozen of minutes. So this is the kind of performance we can achieve there. We align with the Dell tools for the firmware and hardware lifecycle, but I didn't mention there that we also provide the other OEMs tools that are included in the package. So this is the basic architecture of Omnia. So at the very top, we have the infrastructure manager, which is relying on the Ansible recipes, playbooks, with everything to maintain the state, to track the state of the resources that are underneath. Then we have a service cluster. So the service cluster is in charge of the system deployment, telemetry, and a few dependencies and the workload managers. And on the appliances side, this is basically a Kubernetes cluster running the various services like compilation nodes, the Smart Fabric Manager, the Open Managed Enterprise appliance. So everything is connected, and they have been separated for flexibility purpose. From there, we have something which is scalable that allows us to address very large-scale projects, and underneath the hardware will be made of PowerEdge platforms, the NVIDIA, Dell networking. In Dell networking, we have the Broadcade chips, and the Dell storage. It does not exclude that we have third-party hardware that we include in the framework as well, but this is the main purpose of this system. So in terms of system deployment, what we've done, so it's been a long journey with this tool. So we started develop this Omnia in 2018, 2019, and since then we've come across a number of deployment system tools. We've been using Werewolf, we've been using XCAT, but with the changes with the software, so XCAT, has become Confluence. So we had to find an open source tool to go along, because this is very much in the Dell DNA to work with open source tool and bring improvements to the community. We do that as well on the hardware side with the Open Compute project. We are very much active on this project. So OpenCHAMI came right at the right time for us. So the basic idea is OpenCHAMI will provide you with a system deployment service And on top of that, it provides a tracking of all the changes in the configuration. So if you have redeployed, if you have a failure, these kind of things are included in OpenCHAMI. So for us, it came at the perfect time and provided the right features for our tool. So OpenCHAMI includes BSS, so the boot script services to fine-tune your kernel and a few things post-boot, the BIOS, for example, deploy a few firmware. We have the SMD, so SMD2. SMD was a Cray-focused product. But the SMD2 has been made more general purpose, allowing us to describe our own systems. And we have very much the hardware inventory in SMD2. Then Magellan is the discovery service based on Redfish that will feed SMD2. SMD2 will be used by OpenCHAMI to track the state of every system. So it's very much an ecosystem of software that is covered entirely by the OpenCHAMI project. So some of these tools are part of the core OpenCHAMI, and others will be I can't remember the term. It's dependencies. It's side projects, but they are maintained by the OpenCHAMI community. So we match the APIs and the interfaces. So this is although a software which has a growing community, so a growing adoption on the market, which is good. It's based on a microservices architecture, and it provides you with cloud-like workflows, which is exactly what was needed. So with all that. We are now in a position to deploy some very large systems. So we had announced last year Dudna, which is the NERSC future supercomputer. So it will be an exascale supercomputer. And we have announced this week Italia AI Factory as well, which is to be deployed in Cineca. And that will be a very large system as well, made of hundreds of GPU nodes. So all of that is part of a collaboration with these customers, and this is very much the way we want things to be. It's not coming with a software and coming with fixed ideas in terms of what should be in terms of software, but we will collaborate and make this evolve. So Omnia is available on a GitHub. Everyone can contribute to Omnia, and when I see the presentation from Massimo, I cannot see Massimo, but the previous presentation was very much to the point of the kind of things we could think of developing together, coupling those graph databases to explore the metrics at the data center scale, and have this with Omnia. That would be really great. So I think I made it quite on time for the coffee break. If you have questions, I'm happy to take them.
Thank you, Marc.
Hi, thank you for the presentation. So one question, because I didn't get everything that you said. So for the power management, do you have your own tool, or are you planning to integrate the one that OpenCHAMI is working on? Because I saw you integrated Magellan already, so that means you somehow added your Redfish clients there?
Yes.
And I assume the same for SMD2?
Sorry, I didn't get
SMD2 is supposed to also scan the hardware when you create Redfish interfaces and get the hardware inventory, so I assume you integrated that there. So the other tool that I'm missing is for the power management. I don't know if you plan to adapt the one for OpenCHAMI, or you're going to provide that solution differently.
Yeah, so there are several options. For sure, we will still use the iDRAC software to control the platform, but we are very much engaged with community software. So if we can have an open source solution which provides the features, we will choose the community version.
And what interfaces do you provide? I mean, you said cloud interface. I assume you have a HTTP interface for people to interact with. Do you also have a CLI, web interface?
We have a CLI. We don't have a web interface yet. It's depending on the discussion that we had with the customer, we will probably change the decision. But at the moment, the customers are very satisfied with HTTP and CLI.
Okay, and another thing. So let's say I buy a system from Dell, right? And then I get Omnia. And then let's say that 3 years after or 5 years after, I extend the system with the new hardware from Dell. And then the Redfish interface might be different because you develop a new version, whatever. So would you, and let's say for some reason, I don't know, maybe this is not realistic, that I cannot upgrade the iDRAC on the existing machines. So does it mean that we will have to install a new, you will provide a new version of Magellan and SMD2 and whatever else with all the Redfish clients that are needed for the new hardware and the existing one?
Yeah, so this is a typical question that we have from our customers, and till now, so I will put a disclaimer with that answer because the life cycle of the hardware with the new systems for AI has reduced quite a lot. So when on HPC systems we had some nodes living for 5, 7 years, 8 years. That was very typical with AI. The lifetime of a system is probably half, if not a third of this. So it's very difficult to have a long-term vision, but Dell is very much a product management integration company, and we understand the challenges for the users to control their infrastructure on the long term. So this is very much at the core of our work, and everything we can maintain for having compatibility for years and years, we will do it.
Okay. Are you going to stay here for the rest of the day?
Yes.
Okay, thank you.
Okay, thank you, Marc.
Welcome.